In this video, I am going to discuss about the design of binary to BCD code converter. First, let's see about BCD code, or otherwise we can call 8421 code. BCD code is an abbreviation of binary coded decimal. That is a coding scheme relating decimal and binary numbers. And this BCD is a type of binary code is used to represent a given decimal number in an equivalent binary form. The BCD equivalent of a decimal number is returned by replacing each decimal digit in an integer and fractional parts with its 4-bit binary equivalent. In general, BCD codes are also called 8421 code. This is because 8, 4, 2 and 1 are the weight of the 4 bits of the BCD code. Next, BCD code. How we can represent the BCD code? In this code, decimal digits 0 to 9 are represented by their binary equivalents using 4 bits individually. For example, the decimal number 429 is expressed in BCD form. Each decimal number is represented by equivalent 4-bit binary number. So 9 is represented by 1004 and 2 is represented by 0010 and 4 is represented by 0100. So the lowest BCD digit is 0 and the highest BCD digit is 9. So this is the truth table for decimal digit and the BCD equivalent. So the 0 to 9 combinations are used for the BCD code. So in this BCD code, 10 to 15, the total 6 combinations are there. This 10 to 15 combinations are the invalid code. The input is a 4-bit binary code that's considered as A, B, C and D. So with this 4-bit code, we can able to make 16-bit combinations. Then the output should have a 8-bit, but first 3-bit is 0 for all combinations. Then the output can be treated as a 5-bit code. The 5-bit codes are represented as W, X, Y, Z and E. And this is the truth table for binary code and BCD output. For 0 to 9, the binary and BCD codes are the same. Then 10 to 15, the binary and BCD codes are different. Then the input bits are considered as A, B, C, D and the output bits are considered as W. From the truth table, we are getting the SOP terms, that is sum of product terms for W, X, Y, Z and E outputs. Now this is the K-map simplification for output W. Now we are placing the ones to the cells. So we are grouping these 4 ones into single cell grouping and these 1 into another 4 cell grouping. So the output at this point is AB and the output for this combination is AC. This is the K-map simplification for output X. Here the values are 8 and 9. So these two are grouping into single cell. These two ones are grouping into one single cell grouping. So the outputs are A, B bar, C bar. This is the K-map for output Y. Here these 4 ones are grouping into one cell and these 4 ones are grouping into another cells. So the output at this point is BC and the output for this condition is A bar B. This is the K-map for output Z. Now these 2 ones are grouping into one 2-cell grouping and these 4 ones are grouping into another single cell grouping. Now the output at this point is A bar C and the output at this point is ABC bar. This is the K-map for output E. Here 8 ones are present. These 8 ones are grouping into one single cell. So the output at this point is D. So these are from the came up we got the logical expressions. Then from the logical expressions we got the logical diagram like this. This is the logical diagram for binary to BCD converter. Thank you.